I'll be going over the greatest common divisor problem, the UMPIRE steps to try and solve this problem. So we start with understand. Then, so we're given two non-negative integers a and b, given two non-negative integers a and b. We want to find the greatest common divisor between those two numbers. Greatest common divisor. So the GCD of two integers m and n is defined as the greatest integer g, such that g is a divisor of both m and n. Both a and b fit in a 32-bit signed integer. Do not use library functions. So I already have a solution in mind, and I'm going to be using the min and max functions, and I think those are library functions, so I'm just going to ignore that because I would just have to write more code. It doesn't really make any sense to me why I wouldn't use them. So the GCD of two integers m and n is defined as the greatest integer g, such that g is a divisor of both m and n. So for given 3 and 9, we would want to output 3 because that is the greatest common divisor between those two numbers. 3 is divisible by both 3 and 9. For given 4 and 16, we would output 4. And then 5 and 25. Or I could put something like 0 and 0. It would output 0. So in terms of matching, so the way I'm thinking about doing it is that I have to use some kind of if condition to check if it's divisible, or if a number is divisible by both numbers. So checking if the remainder of a number is equal to 0. I also have to use some variables. Other than that, I can't really think of too much. I'm just using integer division or modulus operator, I guess. So modulus operator. Yeah, I think that's it. I can't really think of anything else. Let's see, modulus operator, division. Yeah, I'm just using variables. That's all. So for my plan. So I'm trying to use the Euclidean algorithm for this problem. So I would let's see. So I have to check if either a or b is 0. If it is, return the greatest of those two numbers. So we have 0 and 0, return 0. 0, 9, return 9. 9, 0, will return 9. So that's what we want. Other than that, let's see. Check if either A and B is 0. Otherwise, so I want to use a variable to store the largest of those two numbers. So store the largest, and I would also do this for the smallest one too. So store those largest and smallest numbers in variables. Check if the remainder of those two numbers is equal to 0. If it is, return the smallest number. Otherwise, the largest number, largest becomes smallest, and smallest is set equal to the remainder, So check if the remainder of those two numbers is equal to 0 and store, you want to store that in a variable as well. Okay, smallest is set equal to the remainder. Okay. So for implement, I have to check if A is equal to 0 or B is equal to 0, return the max of A and B. Otherwise, largest equals the smallest. No, wait, largest equals the maximum of A and B. And the smallest equals the minimum of A and B. Then we use a function, no, we use a loop, so while true. So an infinite loop, and then we check if, so we want another variable that stores the remainder of the largest divided by the smallest. Then if remainder is equal to 0, we return the smallest. Otherwise, we so the largest becomes the smallest, and smallest becomes the remainder. And this is the Euclidean algorithm. I'd have to look it up to see why exactly this works, but yeah, I think it's just we check if the two numbers, to get the greatest common divisor, we check if the two numbers are equal to 0. If the remainder of the two numbers is equal to 0. If it's not, we update the largest to the smaller number, and then the smallest number becomes the remainder, and we just keep dividing them until we get 0, and we just update it otherwise. And this is the Euclidean algorithm, and this gives us the greatest common divisor, or should give us the greatest common divisor. And then I kind of did some review there, but this should work, I believe. In terms of its time and space complexity, I'm not sure. I see this loop, so I think it might be O log of n, but I'm not really sure, to be honest. So let's see if it works. Okay, we got all the test cases. Let's see, submit it. Yeah, looks like it works. Okay, thanks. That's my UMPIRE steps for greatest common divisor.